Now we'll try to do a implementation of this. We'll try to do a implementation of this. Okay, and we may say that from the point where we started, that maybe a point will be, let's call that index to be, this was index 1, index 2, 2, 3, 4, 5, 6, 7, 8. Suppose this is like this one. Now let's try to see a code, how do we implement this circular array. I'll try to write it in Java, but you guys can feel free to change into your language of choice. As we decided, our common language will be Java. So in Java, everything is a class. So we define public, and suppose the class is Q. Okay. And as we already said, the Q should support the following methods. So one is enqueue, dequeue is full, and is empty. And everything is in a constant time, O of 1, O of 1, O of 1, and O of 1. Okay. Now let's try to implement each method one after the another. Let's try to implement first, and the underlying data structure that I'm using is int array. Okay. And let's try to also have a capacity. Right. So define public q in capacity. What we do is that this dot capacity equals to capacity, right? And we define array equals to new int, and I pass here capacity. Right. Okay. Now the first thing that I have to write is public boolean is public boolean is empty. Okay. So my data structure is like this. Now, can you tell me what should I say? Now, let me add also one more thing. Like what is my, so two more things like int front and int real points. So initially it is starting, so I can say that front is equals to this one, maybe real is also. So for the is empty condition, what should we write inside this is empty condition, right? What is the code should go like for the is empty one?
If front is equal to rear.
If front is equals to real, that will also can happen when there is one element, right? That is not empty set, because if there is only one element, when suppose I have just added first element, say say I have added element say 9, right? So in that case, front is also this, and this is also rear, right? So front is equal to rear, right?
Front,
So this is not empty. See, when there is only one element, even in the case of the linked list, we saw head is equal to tail when number of element is one.
yeah, yes.
Same in the stack. So if there is only one element, then there is what rear and there is what front. Doesn't make sense, right? Both are the same thing. So if the front is equal to rear, it doesn't guarantee that this is empty.
Like front should is rear minus 1. If
Front should be
like
rear minus
1.
1. So if front and the rear are at the two different position, right? Then it is definitely that it is not empty, no?
No, I will start for like front from -1 initially. Front from -1 and rear should be at 0. Like,
But why the rear should be at 0? So if the rear is at 0, it means that at 0 you have some element. And if suppose if there is no element as such, and you are saying that rear is equal to 0, what you will try to do, you'll try to dequeue the element from 0 position, which actually is not existing. And in the starting of initialization itself, I have defined this condition, right? Front is equal to 1 and rear is equal to -1. Right. This is my starting position, because I know that if I have to DQ, NQ any element, I will go at the front position. And if I have to DQ anything, I'll go to the rear position. Initially, both the front is -1 and the rear is -1. So suppose I have to add a new element. So I'll go to the next front, -1 plus 1 equal to 0. So at the 0th position, I'll go and do it. But right now, when the rear is equal to -1, if I have to DQ it, I cannot DQ it because there is no element in it. So this is what my situation is. Front is equal to -1 and rear equals to -1. So it's very simple. If it is empty, how do we figure it out? We just say that if front is equals to -1 or rear is equals to -1, return true.
No, but my question to you is like, suppose if you added five elements and front and rear reaches to a fifth element, if that is the fifth element, okay. So from one to five, if
Uh-huh.
you're adding that and you're dequeuing it, so you mean to
Mhm.
say automatically both the front and rear indexes they get target to -1
Yes,
internally.
we'll come to that. I got you one very genuine point, and we'll come to that. So we'll have to take care of this thing when I'm trying to do a DQ. I'll have to take care of this one. That when the array gets empty, all the elements are there's no such element in this. We should reset the both the front and the rear to the -1 index. We'll come to that, and that way it will make sense because someday we'll have to define this. Otherwise, it will become very complicated, right? So we'll see that when we are trying to dequeue and we are reaching a state in which there is no more element left in the given array. In that case, we'll put both the front equals to -1 and rear equals to -1 again. So that always this empty check can be valid. So we only have to check whether if the front is equal to -1 or array or rear is equals to -1, it means that it is empty. Otherwise, we'll return false. Okay.
Okay, fine.
Okay. And then second one is that public boolean is full. Okay. Can you tell me how do we define when it will be full? So suppose I keep on adding element into it, right? So for example, uh, 9, then 7, uh, 9, then 7, maybe 15, then 4, then 8, 2, 1. Now once I have come here, I say that this is empty. But how do I say it? Right now my front is this one. This is my front, and my rear is this one. Rear is this one. Okay. So if I say that front plus 1 is equal to rear, can I say that this is the state when I'll say that this is full? Can I say that?
Yes, you can do that.
Okay. So what I can say that return f plus 1 equals to r, right? But I see there is a challenge in this statement. What is that? Can you guys figure it out?
I think the index values. I mean, in this case, f plus one, like uh, front is at index number 6. 6 plus 1, 7 is equal to 0. So
Yes. So what should we change it? Very nice. Very good, Jahid. So what should we do to fix this up?
I can do another condition like when my front is at last index, the rear should be at 0 index, something like that. I don't.
That is very hacky code. We should always
Okay.
try to avoid hacky code, right? This is
Okay.
a kind of hack, and this will unnecessarily add too much of bugging. What you can do is that you can make use of something known as ampersand. If you remember in the array thing also, I told you a logic in which using the ampersand and the division operator, you can store two kind of information in the same array. That was very strong thing. And I asked you guys to please note it down somewhere because that is
Yes,
something
right.
which is very helpful. That is very helpful, right? So
Mm.
here also we can make use of that. So what I can do is that I can just write instead of f plus 1, I'll just write f plus 1 percentage capacity.
Mm.
So what it will do is, so here, what where it is 6, so it will do 6 plus 1, and then when I do percentage 7, value will become equal to
0.
right. But if the value was less than that, suppose I'm right now at 5 only. So if I do 5 plus 1, and then I do 7, it will still remain 5 only. So it will only come into the action when we are about to exceed the array bound, upper bound. It will give us, it will correct us back. So basically, this is the thing, this ampersand thing. This is that magical weapon which is actually trying to. So actually, there's nothing called a circular array. Okay, so we are actually still dealing with a linear array only, right? Linear array only, like this only. So it has element like this only. But as soon as you are reaching here, because of this operator, you are again being guided to this position, and it behaves as if you are working in a circular array. Is it making sense?
Yeah.
So there is nothing as such called a circular array. I'm again repeating. At the end of the class, you shouldn't get confused. There's something called circular array. There's nothing called circular array. There's only was this linear array that we have. But in the linear array, with the help of this operator, which is the ampersand or the modulus operator, right? We are trying to uh, make it behave like a circular array, right? This is very important. This is being used here in the array also. We have used it, and in the several places throughout the data structures and algorithm, we will be using this concept, to avoid any kind of overflow from an array. Overflow from an array. Cool. Now let's move on. So now we are done with the isEmpty implementation. We are done with the isFull implementation. The next implementation is about, let me draw this again here. Something like this, okay? And right now this is my this position is my rear, and suppose this is my front position, okay? Given this situation, I have to now write code for two things. So first one is that public void enq, okay, and int data. What is the first thing that should we write in this enq implementation, guys? What is the first thing that we should check?
If it's full or not. If it's full
Yeah,
or not.
very nice, very nice. If is full, uh, then you simply return, don't do anything. Or you can, if you want, you can throw some exception also, that is, q q is full exception, something like that, right? You can do either of these two things. Then what I can do is that I know what is my front is, right? So if
Yes, sir.
it is indicated by f and if it's indicated by r, I should try to
Increment.
increase the pointer of f and try to store the value here, right? So what I can do is that I can do arr, and this f plus 1, or instead of this, I should rather like write plus f equals to data, right? Make sense? Tell me.
Yeah, fine.
But I see there is an issue here, some issue. What is that issue? Now, at least tell me now. Last time you guys didn't tell me. What is the issue now here?
Sir, when it reached to the last index,
Mm-hmm.
at that time it will increment first, right? In this case, index.
Yes. So if suppose I was here, right? If suppose if suppose the situation is like this, that this was also full 10 and it was 12, and suppose I had already dequeued once. So if I dequeue it once, so this place was 0 position was filled. So the next thing that I have to add was that I had to add into this position. But what I did 6 plus plus. I did a I did a 6 plus plus. So now what it happened? It happened 0, right? It happened 0. So 6 plus 1, if I do, it will become 7. So what I need to do here is that I have to again here ampersand it with the capacity. Does that make sense? Because if I do 6 plus 1, then ampersand by 7, then it will become 0 again. Making sense?
Yes, sir.
Hmm?
Yes, sir. Yes, sir. We
So
got clear.
it's clear, right? So if we write like this, array plus capacity, this is how we do a NQ, right? Uh, Now the next thing that is left is DQ, and this is where we have to pay a great importance, because this is where you have to set the pointers back to -1 also. So the first thing that we do is that we'll do if is empty, and in that case we cannot do anything to, we simply return maybe something, some random number, or if you want you can throw exception also that the queue is empty and you're still trying to dequeue the element from it. Okay, but if it is not empty, now here the logic applies. What should we do now? So let me draw a figure of the worst case. So suppose I have only one element here. Okay, something like this. I have a circular queue, and this one, this one, this one, this one, this one, this one, and I have the elements like this. Say it is index 0, 1, 2, 3, 4, 5, 6, and suppose the element that I'm looking for is here. One element is here. Okay. And at this position, my at right now the rear is also this, and the front is also this. So now you tell me, we have to remove this, that is for sure. So can I say like this? If first of all I'll have to remove the data, right? So what I do is that int data equals to array rear plus, or simply keep it, let's keep it simple. We first figure it out what is the array data at the rear, and then I'll have to do one more thing. R equals to R plus plus. This is normally we do know. If suppose it was, if I have to take out the 5, so initially my rear is here. If I remove out the 5, I'll move in this direction. So one index becomes two index. So it has now R. So I have to increase the index by R, right? This is what we normally do, right? Uh, Now one thing to be taken care of here, is this always correct, or do I have to take care of here also? Is this correct?
So if your rear and front is at the last position of this array,
Rear and front at the last position of this array here. Yes. So
yeah,
suppose 7 was here instead of this. So in that case, the rear becomes RR becomes equal to 7. That will be a problem. So again, we'll have to, very nice. So we'll have to do it with the capacity so that it
yeah.
stays in the range. Okay. Now, once I have done this, so my rear has also moved apart, and no more element is left now. But suppose this is the situation. In this case, my rear has now become equals to 7. Sorry, rear has now become equals to 0, right? But now if I do an empty check, I'll check on the rear or I'll check on the front, and those values are not -1 right now, right? So this will not, if I do empty method call as empty, it will not return me true. So what should I also check and do in this case, so that if there's no element, I set those pointers equals to -1 correctly? What should I do?
So
Tell me.
inside this function, before after checking is empty, I will check like if rear is equal to front. At that time, I will just return front is equal to -1 or something like that.
If rear is, yeah, a very good idea, I think. So what you can do is that you can just keep some boolean. Boolean is last, something like this, and this value is equals to, uh, this value can become equals to if front equals to rear. In that case, you set it as true, else you set it as false. Like this, you can write this statement. This statement is clear to you guys. I've written it like in a vertical direction. Boolean is last, is equal to front, or if the front is equals to right, it means the boolean is last will be true, because that is the only, if there's only one element, then only the both the rear as well as the front indexes will be same. Otherwise it will be false. And if that is the case, after doing this, since it was the last element, I have already removed it. So if is last, what I can do is that I can set front equals to -1 and the rear is also equals to -1, and then I return data. So again, if that is the case, once I've removed this, everything will get reset. So every time, the next time when I add, I will again start adding elements from here. Make sense? Clear to everyone? Vivek, Jahir, Paritosh, are you guys clear?
Yes.
Perfect. Cool. Very nice.